Hi, everyone. We still have about 12 minutes before the session starts. So please feel free to ask questions. Okay, so a question is, in a couple of objectives, for example, objective 16 and 20, we abuse the CIFS service. Will you also show how we can get a shell or a command execution on the hosts in different domains or forests? Okay, so objective 16 is, let me quickly take a look. Which one is objective 16, for example? Constraint delegation, and 20 is cross forest. So in case of delegation, although constraint delegation works across domain trust, constraint delegation cannot work across forest trusts. So that would be, leave a command execution using constraint delegation across forest is not possible. In case of 20, yes, that may be possible. However, I can tell you that it is not used in the exam. One. Second, I have to make some modifications in the lab to show you that one. So, yeah, that's what it is for it. Okay, just give me a second. Let me share a Zoom link with one of your fellow students. So the link is okay. So, okay, that is absolutely fine. However, I can add that in learning objective 20, where we execute a cross forest attack, we will discuss this at that time as well. So in learning objective 20, we access a share across forest trust because we can only access explicitly shared resources across forest. Now, in a real world environment, if there is an actual multi-forest environment, a true multi-forest environment where users actually access resources across the forest trust, then you would then you can use the same method that we use for CIFS service. Let's say you know, or you get to know that there is a server that you can access using WMI. That is, you're allowed to log into a server across forest trust. Then you can create tickets for host and RPCS and RPCSS and use them. So that would be absolutely fine. Okay. Let me share the Discord link with you. Now, cyber student, thanks for you. Now, question is, it would be great if you can explain the second diagram attached to the lab materials. It would be easy to understand the attack vector. Sure. Oops. So this one, okay. I'll make sure that I keep this open and I'll keep explaining that one. Luckbox 72, you have not loaded Power View correctly. Please check out the lab manual. Another question is the command find domain user location is able to find domain admin user, that is SVC admin, on dcorp mgmt. Curious to know how it is able to tap into the session to execute command. Fastflux, I actually answered that already. Let me share the answer with you and I'll also explain that. Because you've asked it here, it would be easier for everyone to understand, but let me share the answer with you. Okay, so a question this is being asked second or third time, that why it was possible to find that there is a session of SVC admin on dcorp mgmt. Recall that we got a reverse shell by abusing Jenkins on dcorp CI. Now that reverse shell had the privileges of CI admin. Now CI admin is a local administrator on dcorp mgmt. We do not know it yet. So when we run find domain user location, a request is sent to the DC as CI admin, and we get a list of all the computers. Now, as the user CI admin from dcorp CI, we send a request to each and every user, each and every server in the domain, and check two things. One, if we can list sessions. Second, if we can list currently logged on users. In both the cases, if there is a match with a membership of the domain admins group, we'll get the output. Now on dcorp mgmt, there is a logon by the domain administrator SVC admin because it is running as, it is used as a service account for a process. For a service or a process, it's in this matter, it would be the same thing. Now, because we are running with the local administrator privileges on dcorp mgmt, we can list the currently logged on users, and we can see that SVC admin is logged on there. And then we proceed with extracting the credentials. So that is why it was possible to see that there is a session of SVC admin on dcorp mgmt. However, you would also note that when we run that, we also see that the administrator, the default domain administrator, also has a session on dcorp FSRV. The reason for that is prior to server 2019, this is fixed in server 2019, if you're targeting server 2016 machines, any authenticated user can list sessions on a server 2016 machines without having to have any special privileges. So when we run find domain user location from dcorp CI, we not only see the output of SVC admin on dcorp MGMT, we also see the output of administrator on dcorp FSR. All right. Another question is, could you please explain from SVC admin, how are we able to get SRV admin? I think you mixed it up, Rasker. So I think it is about the derivative local admin abuse. That is from SRV admin, how we were able to jump to SVC admin. All right. So the student X user, thanks to its membership to the RDP user scope, has local admin privileges on dcorp admin SRV. Now, on dcorp admin SRV, there are multiple users' credentials that are available. One such user is SRV admin. Now, SRV admin, whose credentials we extract here from dcorp admin SRV, has local admin privileges also on dcorp MGMT. So by abusing those local admin privileges, we copy over safety cards and our loader, etc. Sorry, we copied over our loader.exe on dcorp MGMT and then used that to extract credentials of SVC admin from dcorp MGMT. All right, so it is this derivative local admin that helped us in doing that. No, my clock is not off at 30 minutes. It's my local time. So that's 8:30 in the night. Another question is, so when I say that you need not set up a bloodhound on the student VM in the exam, I mean, user one is asking about how to set it up. So I said, set up the bloodhound UI on your host machine, that is on your physical machine, and run only the ingester or collector in the exam environment, and then copy over the zip archive that the ingesters create, and then analyze it offline. All right. So, because to set up the, we already set it up for you on the student VM in the lab. But if you want to install Bloodhound, you need Java runtime, you need Neo4j Graph database, and sometimes you will simply go down a rabbit hole and waste a lot of time setting up Bloodhound. So keep it ready already on your physical machine, so that you don't waste time doing that during the exam. Right. Now let me start the session now. Hi everyone. Welcome to session 3 of Attacking and Defending Active Directory, the Beginners Edition Bootcamp. This is January 2022 run of the class. So we ended the previous session with the discussion on persistence. That is, once we have high-level privileges, that is domain admin privileges in an environment, how can we hold on to those privileges to achieve true domain dominance? That is, we get our domain admin privileges back on demand. That would be true domain dominance. So we saw some of the persistence mechanisms, and let's keep our discussion on or with some more persistence methods. Another popular method is using your own custom security support provider. So what is a security support provider, or SSP? It is a DLL that provides ways to authenticate. For example, Kerberos, NTLM, Cloud AP, WDigest, Cred SSP, all of these are SSPs. Excuse me. Now, Mimikatz provides a custom SSP. Mimilib.dll contains that code. Now, if you enable this SSP on a machine, this logs local logons, service account, and machine account passwords in clear text on the target server. How do you use it? There are two ways of doing this. The easier way is this one. If you run this as a domain administrator on a domain controller, or as an administrator on a non-DC machine, that is, admin privilege is required on your target machine. This loads your SSP in the memory of else's, or in the else's process. However, in my tests, this has not been very stable with server 2016 and 19. In some cases it works, in some cases it won't. So an additional way is that you drop the mimilib.dll to the system32 directory of the target machine, and then make changes to this registry key, HKLM system current control set control LSA security, and then simply add information about mimilib. That's it. You need not reboot the server or anything else at all, and it will start logging all the local logons in clear text in this log file in the system32 directory. So that is how this can be used. There is a very interesting use case of this one. If you add your own custom SSP, this bypasses or avoids credential guard absolutely. Because credential guard would have no idea that this SSP is there. I mean, it would not protect against a malicious SSP. That is what credential guard is unable to do. So if you can set up an SSP, you bypass the credential guard as well. However, one very important thing to note here is the path. Now, is this really useful as a persistence mechanism? You may like to answer this on the Discord server. Looking at the path where local logons are logged, do you think that this is actually useful as a persistence mechanism? What do you think would be the privileges required to read this log from a machine? Admin privileges. And that is something which we do not have. I mean, we have those privileges when we set this up. But later on, when we want to come back and read these logs, then these would not be readable. So in case of a domain controller, if you want, and if you know what you are doing, you can actually modify Mimikatz source code and make this log file. Either, let's say, creating a share on a domain controller is not recommended. So let's see if you are using this on a domain controller. What is a location on the DC that is readable by all the users in the domain? Sysvol. So you can actually go ahead and modify this and write the log file to Sysvol. However, if you do that, please keep in mind that we would be downgrading the security of the target environment, because you would be writing clear text credentials for administrators in a world readable directory. But I'm just giving you an idea that probably you may like to write it there. One very practical way could be you can create, let's say, a directory within, and that's just from top of my head. I've not tested it yet because I'm too scared to test this in any real assessment. One way could be to create a directory inside sysvol and use and set its ACL that only one of the users that you control can read the log file. Or as exploiter mentioned, you simply log it to remote system. A very good example, if it is possible that you can log it to, let's say, a UNC share, UNC path, then that would be the best one actually. If the logging supports it, I'm not sure if that could be done or not. All right, so there could be multiple ways. All right. Just give me a second. Someone else is also asking for the Zoom link. Okay, so that's about the custom SSP part. Now, another persistence mechanism is admin SD holder. Recall that we had some discussion, I believe, on day 1 about modifying ACLs of the domain admin group. All right, let me log on to the DC. So we discussed that if we have domain admin privileges, would this be anything useful? So let's revisit that really quick. Once we have domain admin privileges, let's say we want to control the domain admins group, but without being a member of the group. So what can we do in such a case is we go ahead and modify the ACL. So let's say for student 1, I would like to provide this user full control over the domain admins group. So what does this mean? This means that student 1 would have the ability to add or remove a user to the domain admins group, even reset any of the group members' password. But they would not show up, student 1 would not show up as a member of the group. So we discussed that, is that a valid persistence method? Turns out that actually it is not. There is an ACL sanitization method called security descriptor propagator, SDProp, that runs every hour and compares the ACL of protected groups and members of the group with ACL of a special container called admin SD holder and overrides any changes to the permissions. That is what happens by default every hour is, even if you make these changes, let's make this change. All right, I provide student 1 full control over the domain admins group. All right, as you can see, it is visible here. Now, every hour, SDProp security descriptor propagation reads ACL from admin SD holder, literally admin security descriptor holder. It reads the ACL, this ACL, and overrides the ACLs of all the protected groups. Now, what are the protected groups? These are certain built-in privileged groups. These are some of the protected groups: account operators, backup operators, of course, domain admins, enterprise admins, domain controllers, the domain local administrators group, etc. Now, these groups are considered high privileged enough so that any changes made to their ACLs should be replaced by a known good administrative holder every hour. Now, while it is clear that why enterprise admins or domain admins or administrators should be protected group, why some of these groups should be protected? This is the reason. Account operators, these cannot modify directly the domain admins, enterprise admins, or the built-in admin groups, but they can modify nested groups within these groups. Backup group operators can back up a GPO, edit them, and then restore the group policy. So all of these can provide us ability to compromise the whole domain. Server operators can run a command with the privileges of system by using the browser service. Print operators can copy ntds.dit, that is the Active Directory database that stores all the secrets. It can also load device drivers. So this is the reason why some of these groups are member of the protected groups. Now, how does SD prop or the propagation actually works? So here we can see that our modification is there. Student 1 has full control. Now, in place of waiting for an hour, let me quickly run propagation manually. So for running administrative holder, I need to first have a process running as the domain admin. I mean, this is a legit functionality. I'm just showing this from the student VM because we are manually running. So let's start our process as a domain administrator. Now let me run PowerShell here because we are looking at something that is legit. I would simply like to create a session to the domain controller, a PowerShell remoting session. Okay, probably I used older credentials. Or let me try with safety cards. If Rubius is not liking this, yes, it is not liking it. Let me quickly switch to safety cards, and this is something that I can take a look at later on. So, do I have one for safety cards actually? I have one for SRV admin. Let me quickly modify that one. Yep, I'm aware of that. It is usually when we are hammering the DC, I mean, a lot. So if you faced it, then probably it was the time that you do or you use something that I am using. All right, and that is to quickly switch to another tool, and that is why we are looking at a lot of different tools so that we are not stuck if a tool starts acting funny. So I hope that this works with safety cards. Okay, let's start a session. Okay, so then it is not something that you should do that way. All right, let me reboot the DC then. Should have tried it before lecturing you. but it is fine. All right, I'm usually fine with demos failing all the time. I'm not all the time, but I'm fine with it because, or let me actually copy the propagator. Okay, let me reboot that real quick. All right, so what we are going to do once the DC is back up, it is rebooting, is we will force run the SD prop service so that it restores the ACL for the domain admin scope. To be very honest, I mean, I'm not saying this because this is my lab. This is, I'm pretty sure that this is absolutely nothing to do with the lab. Or if let me be less confident, I'm pretty sure that this is a problem with Windows and could be something with the lab as well. All right. And things like this one, or when we inject multiple tickets and we ask you to log off and log on. To be honest, I mean, and trust me on this, we've tried our very best to find out what is the exact reason why Windows would do that. And I mean, yeah, we have to just either reboot or log off and log on. What do we do if we run into issue like this during the exam? During the exam, you have full control over the lab, so you can reboot the DC on yourself if you feel like it, that this is a problem with the DC. You may like to note that in the exam, you get a dedicated lab. So it would be only you who would be hammering the DC or the lab. So chances of stuff like this are pretty low. So still rebooting. So meanwhile, let me move ahead. We'll come back to this one. Meanwhile, it reboots. So the idea is when we can, I mean, think about it. What's wrong with this? The method or the SD prop, what it does is it reads the ACL of the admin SD holder container and overrides the ACLs of all these groups and their members. What could go wrong here? Would anyone like to make a quick guess? What could go wrong here? What about, I mean, yep, I can see some of you are typing. Make a guess. Okay, so the DC is back up. Exactly. What if we go ahead and make changes to the admin SD holder ACL itself? There is absolutely no additional protection or even no additional logging. If you make changes to the ACL of the admin SD holder, by default, it will, within an hour, your ACL, that this changes, that is the changes that you make to the admin SD holder, that would be propagated to all of these protected groups and their members. All right. So now let's first check if our entry is still there. I would not say it is an inheritance. I would say this is more like propagation, right? That is why it's called propagation. That is, these protected groups are not inheriting the permissions from administrative holder, but a process reads them, reads the entries and overrides. So here we can see that student 1 is still here. And now let's run the propagation. So I've opened up a PowerShell session to the DC. I invoke SD propagator, that is a script that can run propagation manually. And then let's simply run the command loaded by that script on the DC. So as soon as we run this, the SD propagator reads the ACL from the admin SD holder container and overwrites this. So now if I go ahead and open the ACL again, okay, let it complete that. The propagation is still going on. And this is the right DC, right? Yeah. Still going on, but that is actually pretty fast. You need not. And of course, when I tested it before the class, this was absolutely fine. If I go to domain admins group now, oh, come on. Let's refresh this one. Okay. That is something that I'm looking at for the very first time. No, it just, I mean, you need not even wait for the SD prop to complete. I'm sorry, this is the very first time I'm actually looking at this stuff. All right. Otherwise, this ACL is simply, this overrides the ACL of all the protected groups. Okay, let me try that as well. If I just close this and open it again. Okay. Okay, let's run propagation once again. Even if the account is a DA, that would actually replace it. Yep, gone now. Probably there was some issue with propagation. Right? So as you could see, it's not always the lab fault, right? So this is what happens. And to be honest, this is the first time I'm seeing SD prop failing to propagate. Now, what does this mean? This means that the A's that we added, that is the changes to the ACL we did, were removed. Now, what if we turn the tables here and make the changes like this? In place of making changes to an individual protected group, and if we, in place of that, we go and add that to the admin holder group. That is, we add this, student 1 has full control over what? Over everything. So this is the change that we made for the admin holder. All right. Now, if we go and check the domain admins group and its ACL, student 1 is not there yet. Now, if we wait for an hour, when SD propagation runs or SD prop runs, the question is, what is admin SD holder? Think of it as what? A container, not a user or a group. Simply a holder, I mean, as the name suggests, it is something that holds the ACLs of the protected groups. No, not an OU, not an OU. Now, if we go to the ACL of the protected groups, you will see that student 1 is back here. If you go to the ACL of the members of the protected group, you would see that student 1 is here. Go to any of, let's say, built-in group, for example, the domain local administrators group, student 1 is here. That is how we can abuse admin SD holder. And this is not my research. This is from Sean Metcalf, adsecurity.org. All right. The question is, isn't it very unstealthy? Unfortunately, it is. I mean, you will still leave the usual 4624, 4634, and 4672. That is admin logon because you are accessing the DC. But that is it. No, absolutely no additional logs, not even a 4662 by default when you make changes to admin SD holder. Of course, it is recommended in any environment that takes their security seriously. You would expect an audit event, that is a log event, when you make changes to admin SD holder, but there is no such thing by default. Yes, absolutely, this should be monitored. You should actually go ahead and add. I mean, not like this, like I'm doing, not using the GUI, using audit poll or something. You should actually make changes to the cycle that if anyone makes changes to the admin SD holder, there should be at least a 4662 for that. All right. Now, if I remove this from here, remove the ACE for student 1. And if we run the propagation again, you would see that this is gone now. All right. So that is how we can abuse admin SD holder as well. So make sure, as user 1 suggested, there is a lot more data for a production DC. So make sure you do not log the reads of for the ACL of admin SD holder. You log modifications to the ACL of the admin SD holder. So that would reduce your noise and would give you some actionable information. Right. A question is, if you add your user to the administrators group, that adds you to the DA group, not the group, I believe. But that would allow you, if you add your user to the administrators group, that would allow you, I believe, some special permissions, ACLs. So not ACLs, ACLs on the domain admin group. That is, you can add or remove a user at will or reset passwords, etc. Now, how can you do that without using GUI? You can either use Power View. This command does that for you. So what are we doing? We are adding an ACL to an object. What object? Admin SD holder. The principal identity that should have some rights is student1. What are the rights? Full control, for example. In the $COP domain, the principal belongs to the $COP domain and the target domain is also $COP. Or you can use the AD module and the RAISE toolkit. So we can use setDC permissions, the method that we want to add, the user who would have permissions, what permissions, generic all, what would be the distinguished name, this one. So a question is, if you remove the user from the group and it is still in the admin SD holder, will it repopulate after an hour? Yes, exactly, it will. It will. All right, so this is the way we can add full control. Sorry. So got some cold, so had to sneeze. Now, what other permissions can you use here? In place of full control, I mean, full control is fine, but that is not something that we should be after all the time. So whenever we talk about ACLs or any sort of permissions, go for the minimal permissions that you would require to achieve your target. All right, for example, in place of full control of the ability to reset passwords of the group members, that would also work. Or to add or remove members from a group, that is also sufficient. There is no need to have full control over all the protected groups, right? Please always keep in mind, if someone is doing ACL auditing, they would be more interested in those principals that have full control. You would stand out. So go for the minimal permissions, and there is a chance that even if ACL auditing is done, you would still slip through. There is a chance, right? Now, once we have added the permissions and ran propagator or wait for an hour, then we can use these commands to check, let's say to check if the permissions have been added to the domain admin scope. So what is the command here? What is the command doing? It lists all the ACLs, all the ACs or the ACL for the domain admin scope. Now, because get domain object ACL does not resolve identity names, we add an identity name, that is the security identifier. Whatever is the security identifier returned by this command, we convert them to human readable name and then filter it for student1. That is what we are doing. Right, so I'm just showing whatever we have seen using GUI, how we can do that from the command line. All right, we can similarly we can use the AD module as well. Now, how do we abuse? Let's say we add full control, we can add a group member, or we can reset a group member's password. So that is how we abuse admin SD holder. But we are not done yet with ACLs. There is, because recall we discussed, ACLs are central to the access control model in domain. So we'll keep coming back to this. For example, there is another interesting object whose ACL we can abuse. That is the domain object itself. So if you go to its properties and go to the security tab, this is the DACL. Okay, it is already added for my user. Let me remove this. Now, there are many interesting things that you can do by making changes to this. If we have full control over this ACL, we can do some interesting stuff. But that is, for example, the groups like DNS admins who inherit their permissions from this object, we would have control there. But recall during our discussion of DC sync, I said there is a minimal set of permissions that we can use to run the DC sync attack. What is that minimal set of permissions? If you scroll down here, there are two permissions. We use the third one just in case we face a failure. Replicating directory changes, all. These two permissions are the only things required to run DC sync. And you can add the third one, replicating directory changes in filtered set, just in case we get a failure. Any user that has these two or these three permissions can run the DC sync attack against the DC without having any special privileges. However, there is one relief here. If you make the changes, you would see that this shows up by default in the security logs. You would have a 4662 that tells that administrator made some changes on the domain object. What were the changes? Changes to the DACL. Thankfully, this is logged by default. However, now what does this mean? This means that as a normal user, this is running as a domain admin, so not using this partial window, but using this one, I can now simply go ahead and run the DC sync attack. You see that? I've requested the secrets of the Kirby TGT account that allows us to create golden tickets, and it is right here. All right, and if I remove this, we can't. All right. However, in this case, because it is logged by default, anything that is logged by default, at least that is something we would assume that will result in bells and whistles. But it is pretty interesting, still pretty interesting to be honest. Yeah, as White comma mentioned, this is immediately an alert in my log manager, and it should be. Right? This is default logging. If you miss this, then there is a problem, a real problem to address. All right, now how do we do all of this from the command line, for example? So recall that we are in the persistence part. We need domain admin privileges to set up a persistence, but we do not need them to use it. So let's load Invisi shell here. So what are we first going to do is check if our current user has any privileges to run DC sync. So let me load up Power View here. And let's run this command. I'll explain this command in a moment. So we got no output. That means currently we do not have the permissions. And now, when running as a domain admin, let's start Invisishell, load a Power View, and then add that on the domain object, student1 would have DC sync rights. Let's run this. Now, if we go back and run this command again, we get that on the domain object, $corp money corp local, dcorp student1 has the following rights: DS replication, get changes in filtered set, get changes all. That is, we have the DC sync permissions. How do we create it or frame this command? List all the ACLs just for the domain object, nothing below it. Search scope base means that we need to list ACLs just for the current object and not the child objects. Then this question mark is an alias for where object, the de facto filtering mechanism in PowerShell pipes. So from all the entries returned by this command, we want to take a look at only those where object is type matches replication get or generic all, because a user with full control would also be able to run DC sync. This command up to here lists all those ACEs where any user or any principal has either replication or full control rights. Now, but what we want is we want to check if the current user, student1, has any such privilege. Now, get domain object ACL, even if you use resolve bits, does not include an identity name, right? What it includes is only security identifier. So what we do here, for all of the ACEs written by this command for each object, we add a custom property called identity name. And what would be the value of it? We use the convert SID to name function from Power View to convert security identifier to a human readable name. And the label would be identity name, property would be the human readable name, and then we filter it out on the basis of identity name. That is, if only identity name matches student1, only then the ACE should be listed. All right. Now, question is, why were you allowed to do this as a normal user? This is just reading the ACLs. This we did as a domain admin. That is, we set it up as a domain administrator and we can use it as a normal user. Oops. This is just a read operation. All right. Another question is, how can we know when to run DC sync or admin SD holder? Well, admin SD holder is a pure play persistence mechanism. If you want to hold on to your privileges, you use admin SD holder. DC sync is a credential extraction mechanism. You request or you extract credentials. So these are two different things. Whenever you want some credentials, you use DC sync. If you want to persist, hold on to your privileges, then use admin SD holder. All right. So this is what we did to add DC sync rights. And then we can simply go ahead, as we saw, and run the DC sync attack. And this is in fact our learning objective 12. Check if student X, that is our student user, has replication rights. We checked that, and before we set it up, we had no such rights. If we have the rights, then execute the DC sync attack. If no, then add the replication rights for student X using our domain admin privileges. We use this command to add those rights. All right, for student 1, DC sync rights on the domain object. And then we confirmed it if we actually have those privileges, those permissions, yes. And then we can go ahead and execute the DC sync attack as the student user. Right. So here, as you can see, okay, let me refresh the ACL. So we added it using the command line. Let's see if it is visible here. Of course it is. Just these 3 rights. All right. Continuing our discussion on persistence using ACLs, let's talk about security descriptors of securable objects. What are securable objects? Some remote access methods like WMI, partial remoting, remote registry are called securables. Now, if we modify the security descriptors, that is ACLs, of these services or securables, it is possible to access a remote machine without having admin privileges there. That is, if you have admin privileges on a machine, you can make changes to some of these securables and it will allow you to access that machine as a non-admin user. All right. And this is something I believe has been known for at least, what, 4 or 5 years now. And of course, there is no fix. There is nothing that Microsoft can fix here. However, there has been no way of detecting these by default, or I mean, I don't think there is any detection guideline as well from Microsoft on this. So what I'm talking about is this. Now, these securables have security descriptors written in SDDL, Security Descriptor Definition Language. Now, SDDL defines the format that we can use to describe a security descriptor. So this is, for example, how an ACE looks like. There would be an ACE type, any flags, rights, object good, any inherent object good, and account SID. For example, take a look at the ACE for the built-in administrator group for WMI namespaces. ACE type is allow, ACE flag is container inherit, rights are create child, delete child, list child, and so on. And here is the SID of the account, the security identifier of the account that we control. And that is the only thing that we want to do here. That is, if you want to modify the ACE for WMI namespaces, you can pick up the entire SDDL and just replace this by SID of a user that you control. So this can be done using the RACE toolkit. So what happens if I run this command? As a domain administrator, if I run this, student 1 would be able to access this namespace, this WMI namespace on the domain controller without having admin privileges. But before that, let's see how this works. Let's understand how this works. Now, whenever you authenticate to, or you try to access a machine using WMI, ACLs are checked in 2 locations. One is the DCOM endpoint. Let's see the COM security tab here. you have ACLs here that need to be modified. That is one. Second place is the ACL of WMI namespaces. So if you look at the ACL of this namespace, for example, the root namespace, this is where the ACL for the namespace is checked. All right. Now, what this command does, let's run it. Will not specify namespace. If we do not specify namespace, then changes are made to the ACL of the root namespace. So let's do that. Once again, while setting it up, we would need domain admin privileges because we are doing this against the DC. So do we have InvisiShell running here? Yes. So let's load the race toolkit. And let's run this. So what happened is this tool read the existing ACL for root namespace and for decom endpoint, and then simply copied the one for built-in administrator and added SID of our current user. Not the current user, the user that we specified here, student one. Now, what does this mean? This means that as a normal user, we can go ahead and do this. Oops, not this. Why? Let's just check this again. You see that? That's the reason. All right. This command we ran as a normal user, absolutely not as a D. And now, unfortunately, just like changes to the admin SD holder, there are no logs that are created when you make these changes. And this works very well as a low-key backdoor. However, there is a catch. Or let me discuss that catch in a moment. You can similarly do this, do the same thing with partial remoting. However, please keep in mind that PS remoting backdoor was not stable after some August 2020 patches. But after the October 2021 patch cycle, this has started working again. Otherwise, for around a year, the PS remoting backdoor was not working for some reason. Now it works absolutely fine. Right. So let's try this now. Or before doing that, let's understand what happens. And even before doing that, let's remove what we added here, the permissions for the student one user. All right, I've removed those permissions. And now if I try to run this, I get an access to it. Now, what happens when we PS remote to a machine? There are PS session configurations. All right, and this is the default one that you connect to Microsoft.partial. So if you run this command, set PS session configuration, specify the name, and use show security descriptor UI, you can add a user and add them to have, let's say, full control over here, and then that user would be able to connect to this machine using PowerShell remoting without having admin privileges. Let's do that from the command line. So once again, using the race toolkit, let me clear the screen first. All right, if you get this error, I'm glad that this error showed up. If you get this error while using this command, this simply means that WinRM on decop DC did not close the operation gracefully. This does not mean that your command has failed. And a very easy way to check that is actually try and access the DC now using PowerShell remoting. Right? Now the catch that I said I'll discuss later. The catch is this. All right. We are still the user student one, a very low level privilege. We do not have even the adjust token privileges so that we can hope for any privilege escalation. Cool that we can access the DC, but not so cool that we would still have privileges of only a normal user. All right, I mean, you got to stay into the presidential suite, but you cannot touch anything. All right. So what can you do? We can look for some usual privilege escalation opportunities. For example, check if there is any service that has any permissions issue or unquoted paths, etc. I mean, those all of them are all the privilege escalation opportunities would be valid now. So a question is, do we have system privs on the DC? No, absolutely not. That is why I ran a whoami/all. We have the privileges of student one. And these all are the exact privileges available to this user. All right, so that is what I expect here. I mean, these two are cool, cute, right? WMI security descriptors and partial remoting security descriptors. These are cute, but so what? I mean, I expect a shrug here. I mean, all of you are pretty polite to do that, but that is what I expect here. I mean, yeah, so what? If you can do that, what's the point here? The point is, as Guy with the code mentioned, we can change this with stuff. What stuff? Stuff like this. Now, the third securable is remote registry. And this is where things start getting more interesting. Now, if we set this up, the third one, that is, we are making changes to one, to the ACL of remote registry. Two, we make changes to several registry keys that hold secrets. All right. Once this is done, we can go ahead, load the rates toolkit as a student user now, and extract secrets. What secrets? What are the credentials that are stored in registry? Machine account hash, local account hash, and domain cached credentials. So the most interesting one for us would be the machine account hash that we can extract using get remote machine account hash. Once again, if you face any error like this, you can simply start a new session and you would be fine. So let's start a new command here. And if you now run get remote machine account hash, what you would get is the NTLM hash of decop DC. Now, what can you do with NTLM hash of the machine account? Silver ticket. All right. And that is what our learning objective 13 is. Modify security descriptors on DCOP DC to get access using PowerShell remoting and WMI without requiring administrative access. So that is one. We've already done that. Now the second task is retrieve machine account hash from DCOP DC without using administrator access and use that to execute a silver ticket attack to get code execution with WMI. So we have the hash here. Let me copy that. And now we can use invoke memory cards, better safety cards, or whatever you want, whatever your favorite cards version is, to inject a couple of tickets. What couple of tickets? Because we are asked to get command execution using WMI, we need a ticket for host service and another one for RPCSS. Another one for RPCSS now. What does KList purge do? It purges or removes all the tickets from memory. All right, if now I run KList, you would see that we have two tickets, one for RPCSS as administrator on DCOP DC, another one as host. All right, and now we can simply go ahead and access the DC. And that's just an example. I mean, Win32 operating system is not really the class that you would be using. It would be Win32 process or Win32 service or schedule task or anything similar. All right, create it for HTTP service. Use HTTP here and you would be able to use WinRM, that is PowerShell remoting. However, in our lab, because DCOP DC is a Server 2016 machine, that would not work. I mean, that's not, once again, not our lab's dependency or a problem. That's with all the Server 2016s out there. All right. User 01, as you see, I'm pretty sure. I mean, there are issues with the setup sometimes, but in a lot of cases, you will find out there is a small mistake, a dash missing somewhere, or something like that that would lead to it. Otherwise, as you could see here, we can actually inject a large number of tickets. All right. I mean, to be honest, the problem with silver tickets, sometimes if you are repeatedly getting access denied, is the KDC maintains a negative SPN cache. So if you keep repeatedly try accessing a service and you get access denied, then your user may be registered in the service, the request you made may be registered in the negative SPN cache, but that is just for 15 minutes. So if you're repeatedly trying it and getting an access denied, then maybe just go grab a coffee, take a stroll, and probably it will work after that. Even if that doesn't work, then you may like to ask the lab team and they will reboot the stuff for you. Right? I mean, to be honest, we've made it very, very stable. But a lot of times when so many of us are hammering the DC and trying to break it, then it breaks. All right. Another thing in this case is, if something is absolutely not working for you, then just take the lab manual as gospel truth and accept it. That, okay, this is something that would work. I trust this guy, and let's move ahead. So that is also an option. I mean, but not for do not trust me for more than a couple of learning objectives. I mean, not me, the lab manual. If it is absolutely not working for you for, let's say, more than a couple of learning objectives, then there could be a problem. I mean, a lot of times what happens is that I've personally observed is some users would go ahead and try the DNS admins abuse that we have in the slides, and that would absolutely break the DC. And then the handful of users who are sharing that DC would face the issue parallelly. Many times, many times my team covers both. We cover the EMEA working hours. All right. So the users who belong to the US time zone, they might raise a request exactly at the time my team goes offline. So you would see that, okay, your request is served, let's say, in 10 hours or 12 hours. However, I can tell you that our internal, I would not use the word SLA, but our internal turnaround time is not more than, I mean, we have hard set it for 24 hours. Absolutely nothing is pending for more than 24 hours. And we usually get back to users within 12 hours. My team is based out of Singapore and India. So for us, the US timing is sometimes, I mean, we do have a US team that supports it, but not all of them are technical enough to support everyone's request. All right. No need to do that strict, because that attack is finally fixed with, I believe, with November 2021 patches. After like 4 years, the DNS admins issue that we have in the slides, that is finally fixed. Microsoft assigned it a CV and patched it finally. So no need to do that. All right. So what we have done up to now, we have seen multiple ways of persistence. All right. Now let's step back a bit. Recall how we escalated our privileges to domain admin. Those were these two methods. We extracted credentials of SVC admin from the dcorp MGMT machine using our reverse shell on dcorp CI and using or abusing the derivative local admin from dcorp admin SRP. Both of these methods allowed us to escalate to domain admin, and then we jumped right into persistence part. Now let's step back a bit and check if it was not possible for us to escalate our privileges using these methods. What are the other ways of escalating our privileges? First and foremost, Kerberoasting. I'll come back to this slide in a moment if required. So what is Kerberoasting? Recall our diagram on how Kerberos works. All right, and as I said, at that time, we'll keep coming back to this diagram. And here we are, back to this diagram. So what happened in step 4 was, when we presented the TGT to the DC and requested a TGS or a service ticket, the DC responded with a TGS. And once again, as I said earlier, what I'm referring as TGS, some documentation refers as silver ticket, some documentation refers to this as a TGS. I personally like to use the word TGS because that is something that a lot of other security folks use, and I'm now pretty used to this. So in step 4, the KDC, after validating the TGT, responds with a TGS that is encrypted using target services NTLM hash. Please keep in mind, I say this NTLM hash. This could also be AES, but I use the word NTLM hash to keep it simple. Now in step 5, the client or the user's machine presents the TGS to the target service for access. However, in Kerberos-ting, in place of sending that ticket to the target server, we save it to the disk and brute force it offline. All right. So what is the benefit of offline brute forcing? You can throw absolutely whatever computing power or GPU power that you have. There is no log-on count or anything that is incremented, no lockout, nothing at all. So this is what the Kerberos-ting attack is. You request a TGS, that has a part of it encrypted using RC4, that is NTLM. NTLM uses RC4 encryption because RC4 is easier to brute force. We can then do that. All right. This is what the Kerberos-ting attack is. Now, there are a couple of things to keep in mind here. One is machines are good at passwords. And all the interesting services on a machine run using machine account as the service account. Now, machine account passwords are super long and very, very, very hard to brute force them. So what we would be looking at is, we would be looking for those service accounts that are actually user accounts, that is, whose passwords are not set by machines, but are set by users. All right. There was a second point I was about to say, but no, I lost it. I'll come back to that in a moment. All right, so how do we find out users whose accounts are used as service accounts? Okay, so the second point was, if you reread step 3 and 4 here, you would see that absolutely nowhere the DC validates if the user requires any privileges to request a TGS. What does that mean? That means that as a domain user, you can request TGS for pretty much any service account without having to have any special privileges. All right. Now, because we want to target only user accounts, how do we find them out? You can either use the AD module. So the AD module, I like it more than PowerView in some cases, or in many cases, because if we use it, we actually get to know what we are trying to do. So for example, what we are doing here, we are listing all the users in the domain, but we want to, we filter out only the ones whose service principal name is not set to null. Or we can use get domain user -SPN from PowerView. This means, and this is very interesting, this means that any account that has the service principal name property not null is treated as a service account by the KDC, and we can go ahead and request a TGS for it. There is absolutely no need that any such account is actually used to run a service on a machine. If it simply has the SPN property populated, it is a service account for the DC. The DC would not check if the account is actually used to run a service or not. All right, so that is how we find Kerberos stable accounts. A question is, will group managed service accounts, GMSAs, be considered to avoid Kerberos-ting? Absolutely, absolutely. That is the recommended way. However, there is an additional problem with GMSAs. If you allow, if the users or groups that are allowed to read the GMSA passwords, if that list is overly permissive, it would be possible to retrieve the GMSA hashes from such a user for the GMSA account. Now, In a lab environment, a GMSA would be set up, let's say, for one server or a couple of servers. In a production environment, a GMSA may be protecting or being used against a cluster of servers. So if the ACL that allows someone of a security principal to read the credentials of GMSA is overly permissive, or if you compromise one such user, you would have privileges on the entire cluster of servers. I mean, GMSA is still much better than using a user account as a service account, but it has its own set of issues. Right? Now, we can either use AD module or PowerView. Just give me a second, I need to grab water. So we can either use AD module or PowerView, or we can also use Rubius to check for Kerberos-stable users. So let me run this now. I mean, before that, let's run. The Kerberos-stable accounts using PowerView. So it shows up 3 users here. Kirby DDT always shows up. Why? Because it has a non-null service principal name. All right. Another one is Web SVC. It has a service principal name, which is this one. And the third one is SVC admin, our suite domain administrator account. That has this one. Now, a question asked at the very apt time is, why would anyone like to set a service principal name to a user account? This is it. I mean, you need not set it manually. For example, here, if you look at this SPN, there is a SQL server on dcorp MGMT that is using SVC admin as a service account. So this is auto-populated in this case. So either you set it up for discoverability, or the service can set it up automatically. All right. Now, of course, we are going to target SVC admin because it is a domain administrator. I mean, SPN management is such a beta that a lot of times, I mean, services registers their SPN automatically if they are running with domain admin privileges. And SPN management is such a beta that a lot of organizations run their services with domain admin privileges to avoid that headache. And GMSA actually has automatic SPN and management as well. So coming back to this one, let's close all of these so that I do not have a large number of command windows open here. Right, let's just run one right now. We want to use Rubius. To list the stats. So Rubius listed that there are 2 users, 2 Kerberos-stable users. Both support the RC4 encryption type, and password for both was set a couple of years back. All right. Now, let's go for TGS of the user SVC admin here. So that's the part, that's the secret that we can pass, let's say, to Hashcat or John the Ripper and have them brute force this one. All right. However, tools like ATA or its successor, Microsoft Defender for Identity, MDI, and some similar tools have a problem with encryption downgrade. Now, what is encryption downgrade? When we request an encrypted blob like this is encrypted using RC4. Now, if your domain has all the domain controllers later than Server 2008, and you still request a TGS encrypted using RC4, the encryption type would be 0x17, and it would be very apparent that 8 is a forceful encryption downgrade. And that would result in an anomaly and possibly detection of Kerberos string attack. So what can we do in this case? If we use the /RC4 OPSEC option, it looks only for those accounts that support RC4 HMAC explicitly, so that there is no chance of triggering an encryption downgrade detection. So if I run this here, if I add RC4 OPSEC here, you would see that I still get that hash. This means that SVC admin supports RC4 OPSEC. RC4. Let's test that. So if I go to the DC now, and for the user SVC admin, I check. This account supports AES 128 and 256-bit encryption. Let's do that. Now, if I run the same command here, you would see that SVC admin does not support RC4, so the hash would not be requested. All right. So always make sure that you use RC4 OPSEC to not trigger an encryption downgrade detection. All right. Let's remove this. And now if I run this, we'll get the hash again. All right. Now, as you can see here, that's not only for checking. As you could see here, we were able to get the encrypted blob. So the question was that, is that RC4 OPSEC switch only for checking? Absolutely not. We can request the hashes. Once we have the hashes saved to a file using the out file parameter, we can pass that on to John the Ripper. Of course, the possibility of success and the speed with which you crack these hashes, if you do at all, depends entirely on how good and customize your word list to the target environment. Make sure that your word list contains season at year and month at year, right? In a reasonably large environment, at least a couple of users, a couple of service accounts would have such password. And that is why on the very second slide, when we started enumeration, we looked at the password policy as well. If the organization forces their user to change password every month, then be absolutely sure that there would be a lot of month at year, season at year, etc. kind of passwords. Please note that Attacks like Kerberoasting or any other tool that require any other attack that requires any sort of brute forcing or word list are not absolutely used in the exam. You are not required to run any such attack. Do we require local administrative access for Kerberoast? No, absolutely not. Normal domain user privileges are enough. All right. And once, John, if your word list is customized as it is in the labs, then you will have results pretty fast. And please make sure, I mean, we are doing it in the lab so that you need not set up John the Ripper separately. Please do not run John on your foothold environment. All right, you do not want to get caught just because of the CPU spike that you have there, right? Run it on anywhere, not on your foothold. All right. And this is a learning objective 14. Using the Kerberoast attack, crack password of a SQL Server service account. Pretty short and sweet. So we've already decided that what would be a target, SVC admin. It is a SQL Server service account and a domain admin. All right, so we'll simply specify out file here. Let me remove the previous one. So I simply want to save it to c80tools hashes.txt. All right, those are our hashes. Now, if we do not remove this, this is because of, I mean, this is a limitation of JTR, John the Ripper. If you do not remove this :1433 and we run John the Ripper here, it would not be able to load your password hashes. You have to actually remove this :1433. That is a limitation of John. We remove that. And now if I run this, you can see that this was pretty fast. I mean, of course, it is a lab environment. It is set up. I've injected this password in the dictionary already. This is how the success would look like. It was an RC4 hash, Kerberoast TGS, and we were able to pretty quickly brute force it. All right. That is what learning objective 14 is. And the infamous Kerberoasting attack is. One very important thing to keep in mind, whenever you are using Kerberoasting in a real world assessment, there are scripts like, for example, there is a command, I believe, in PowerBrew, invoke Kerberoast, or any such tool that requests a large number of TGS in a very short span of time. Do not use those tools. Detection tools like MDI specifically look for tools that would request a large number of TGS in a very short span of time. Is it pronounced KRBTGT or KRBTGT? I mean, whatever. I say it KRBTGT because it is faster. But use whatever you want. I mean, I'm not sure, not the best guy to ask for pronunciations. I'm not a native speaker, I'm an Indian. So not the best guy to ask on how to pronounce stuff. So I say it KRBTGT because it is faster and easier. All right. Thanks. We do have native speakers on Discord, so if someone can answer. I mean, I've heard people using both the words. I like the second one, the KRBTGT, that is faster. Right? So, exactly. I've seen it. I mean, I've seen people even from Microsoft's own engineers. I've heard both the words. So I like the KRBTGT one. So when I was young and impressionable, then I heard that word and that stuck to me. So that is absolutely fine. Okay, so let's move on to some of the variants of curb roasting, that is targeted curb roasting. In some cases, a user's user account control may have a setting that it does not require Kerberos pre-auth. A setting like this. If a user has this setting, do not require Kerberos pre-authentication. If this setting is set for an account, that means that the pre-auth part, the first step in the functioning of Kerberos, that would not be required. What does that mean? That means that we can make a request on behalf of that user from the DC, and the DC would respond with an AS wrap message that would have a part of the message that is encrypted using the user's password. So it would be possible for us to brute force that offline and get that password if the user has do not require Kerberos pre-authentication enabled. Or if we have sufficient rights, generic right or generic all over a user, we can force remove it. I think the only one setting or a couple of settings I've seen this to be used in production is couple of times I have seen some Oracle products requiring this, do not require Kerberos pre-authentication. And in a few cases, if there is an additional Kerberos rule, but it is not the Windows implementation of Kerberos. So for example, if a user is coming from a Linux Kerberos rule and the ticket is passed on to the Windows Kerberos or some setting like that, in those cases, I've seen this enabled. Other than that, absolutely not. And in some cases, some VPN. All right. So how do we enumerate accounts that have Kerberos pre-auth disabled? Using PowerView, we can use get domain user pre-auth not required. Using the AD module, we can have the filter does not require pre-auth. Once we have such a list of users, in our lab, it is the control X users, that is where X is your user ID, that has, no, not the control X, it is the VPN X, I believe, yes. So there are two set of users where you can practice this. There is a set of users called VPN X users that already has pre-auth disabled. Then there is a set of users called control X user, where the RDP users group has full control. So you can forcefully disable pre-auth there. In both the cases, using the AS wrap roast toolkit that you can find in the C80 tools directory, you can request an encrypted blob from the DC on behalf of this user and then brute force it offline. All right. So there is no hands-on for this one. I've seen this increasingly less and less in production environments, but still a good thing to know. Another variant or another targeted curb roasting method is forcefully set SPN. All right. As we discussed a few minutes back, you can request TGS for any account whose SPN is not set to null. That is, if there is a valid string in the service principal name attribute of a user, KDC will treat it as a service account and you can request a TGS for it. Excuse me. So if you have generic all or generic write permissions over a user, there are a couple of ways that you can use to abuse that user's privileges. A very brute way, a very battering ram sort of way is to reset the user's password. If you reset that user's password, you instantly get access to whatever the accounts or resources the user have access to. But that would lead to detection because there would be one, there would be logs. Two, the legit user will lose the access. So another way is that you set an SPN on the user and then Kerberos the user. All right. How can you do that? You can do that using PowerView or the AD module. So there is a set of support X users in your lab instances where you have full control over that user. So we can go ahead and set the SPN. So there are just two conditions required to set SPN. One, it must be unique for, there's a typo here, that must be unique for the forest. All right. So no, doesn't look like that I've written forest here. So it must be unique across forest, not domain. Now, second condition is it must be in the form of string / another string. That's it. This is a valid SPN. There is absolutely no need to have, I mean, the idea is that this would be the service name and this would be FQDN of the target server. But there is no validation here. You can write whatever you want here. I mean, we have written literally whatever here. All right. So that is how we set the SPN here. And now once we have set up the SPN, we can now request a TGS for it and brute force it offline. All right. So that is all about Kerberosing. Are there any questions? Yes, I already explained that on the very first slide here. Do we need specific permissions? Yes, generic all or generic write on the target user. All right, so you do need them. All right, RDP users has those permissions on support X user. No worries, no worries. All right, if you have, I can see some questions about the exam. Make sure that you read the exam page in the lab portal that answers these questions. Now, continuing our discussion on privilege escalation. Delegation. So, in the beginning, there everything was accessible or supposed to be accessible within the directory. That is, there were a couple of scenarios, and there are still some scenarios that require delegation. So let's understand it in two ways. Let's say there are 3 servers. A, B, and C. Domain admin. Let me try to create a tiara here. Okay, looks good. So a domain admin accesses server B as DA or any other user, I mean a user who has the privileges to access server B. All right. Now, they want to access server C from server B. However, this would not be allowed. Why? I just read some funny comments, that's why I'm smiling. So, why this would not be allowed? Because by default, Windows machines would not delegate your credentials. Credential delegation is not enabled by default. That is, server B will not forward your credentials to server C unless you have SSP like CRED SSP that you used for authentication, or delegation is set up here. Or you use explicit credentials. I mean, if you use explicit credentials from B to C, then there is no point of delegation. I mean, you are providing credentials in any case. This is first hop. This is second hop. And this is what the classic Kerberos double hop problem is. All right. Do you want to see this in action? This is what Kerberos double hop problem looks like. A very simple example, net user DOM, right? The classic user enumeration command, although detected a lot nowadays, but let's just use this as an example. All right, so this is fine. Dcorp admin SRV is the first hop. What just happened here? If I try to enumerate users using net user DOM from Dcorp admin SRV, I get an access denied. Why? Because this becomes Dcorp admin SRV, and this is the DC now. So the admin SRV server refused to forward your credentials or delegate your credentials to the DC, and therefore you got an access denied. This is what the classic Kerberos double hop problem is. And this was rediscovered with the advent of PowerShell remoting to manage services. Why? Because this would, in a lot of cases, this would be the jump VM, when this would be the target server that has to be administered. And the administrators rediscovered that, okay, there is some PITA called delegation. Now, this is a more modern problem. That is, that came back up, let's say in 2013-14-ish, or probably a couple of years earlier, 2012-13. But this problem, the problem with delegation, is something that Microsoft's customers have been facing for decades. So before this, there was a problem of problems that the web users faced. So what was the problem? Let's say a user wants to access a web server. So the user authenticated with the DC and then presented their TGS to the web server. Web server is the first hop here. And there is a second hop, which is a database server. Now the basis of security is need to know basis, right? That is, a user must be able to see only the information that they are allowed to see, they must see. That is, the web server must be able to retrieve only that information from the database server that the user is able to see. Now, this user may be able to see only limited information, then there could be another user who would be able to see their own set of information, then there could be more users. That is, the web server must have a way to impersonate the user and access the database server as these users. And this was the double hop problem that Microsoft's clients faced in early 2000s. That is, how do we allow the web server to delegate user credentials? Or in simpler terms, how do the web server impersonate the users that authenticate to it? And that is the goal of any delegation. We use the end user credentials to access resources hosted on a different server. All right. So there is a lot of text on the slide. There is no need to get overwhelmed. Use this as a reference slide. Right now, focus on what I'm saying. So user impersonation is the focus of any sort of delegation. Now, what are the types of delegations? There is general / basic or unconstrained delegation that allows the first hop server, this one, to access not only the database server, but any other resources, including the DC, as the incoming user. That is, it is unconstrained, without any constraints, without any rules. Then there is constraint that has some rules, but that is something that we'll cover later on. All right. So is this clear? What is delegation and why is it used? Now, once that is clear, now let's understand unconstrained delegation. So steps 1, 2, 3 are pretty similar to the Kerberos steps that we saw earlier. Step 1, Kerberos pre-auth, a timestamp encrypted with the user's NTLM hash is sent to the DC. User secret is sent to the DC. The DC decrypts that, returns a TGT. Step 3, the user provides that TGT and requests a TGS for the web server. At the end of step 3, the DC checks that, okay, this web server, or let me say it this way, step 4, the DC sends the user or TGS for the web server, but the user's TGT is embedded inside the TGS in step 4. All right, the TGS in step 4 has the user's TGT embedded inside it. Step 5, the user or the user's client, that is user's machine, presents that TGS to the web server. Now the web server can decrypt the TGS. Why? Because the TGS is encrypted using the web server service account. So, and this is just a representative diagram. Please do not use this anywhere because this is not technically absolutely correct. Think of it this way. Now, what the web server could do is extract the TGT from that TGS. And then it sends that TGT to the DC, thereby authenticating to the DC as this user, and then it requests a TGS for the database server. And then finally, step 7, the web server uses that TGS to access the database server as this user. That is, the impersonation is finally completed. This is what unconstrained delegation is. And this is obviously dangerous. Why? What if this user is a domain admin? This means that at the end of step 3, the web server will literally have the TGT of the domain admin. That means that if the web server is compromised, that means that the attacker who compromised the web server would be able to extract the TGT of the domain admin and access any resource, including the DC itself. So let's see how we can abuse this. You can read these slides later on if you want the explanation of what I said just now. I mean, if you just want to have it in writing. So how do you abuse unconstrained delegation? The first step, of course, is to find out machines that have unconstrained delegation enabled. So if I run this, let's say this Power View command, so oops. So if I run get domain computer unconstrained, you get a list of 2 machines. Domain controllers will always show up. And then there is another machine called dcorp app SRV that has unconstrained delegation enabled. All right. Now, once we have found out the machine, we must compromise it. That is one step. And then we must trick or wait for a domain admin to connect to a service. Once we have one such domain admin or a high privilege user connected to it, we can simply export the TGTs. And then please note that both TGTs and TGS are portable. That is, you can extract the TGT from a machine and then you can import it on any other machine. All right. So you can extract the TGTs and then inject it anywhere else to get the domain admin privileges. However, this need to trick or wait for a domain admin to connect to a service was removed with the awesome find of the printer bug. Now, what is this printer bug? Discussed, I think, in the last DerbyCon 2018, by the guys who wrote Bloodhound. What this does is, there is a feature in the MSRPRN protocol that is used by the spooler service, the printing service. And that feature is any authenticated user can use the MSRPRN and message a server that please notify me on the other server. So here we are telling server 2, please notify me on server 1. And server 2 connects with the machine account to server 1. Now, if this is the DC, and this is the machine with unconstrained delegation, that is app SRV in our lab environment, this would be dcorp DC $. So what does this mean? This means that we can trick, or not trick, we can force the domain controller to connect to this machine and to AppSRV, and from there we can extract the TGT of the machine account. What is the worst that we can do with the TGT of the machine account? We can run the DC sync attack, for example. All right. So how do you capture the TGT? Using Rubius. How do you trigger the authentication? How do you trigger this connection? Using MSRPRN or spoolsample.exe from this repository. You don't need any special privileges for this one. This command can be run as any domain user. This you need to run as an administrator on dcorp AppSRV. I mean, you need to have access to the machine. So yeah, we would require an administrative access on this one. With that, we can go ahead and use it. All right, or you can also use Petipotam for this. So we can run in place of spool sample or MSRPRN, we can use Petipotam as well. Why Petipotam? Because it uses a different protocol. It uses a function of MS-EFS RPC, encrypting file system remote protocol. It doesn't even need credentials when used against a DC. That is, it can be run even from a non-domain joined machine. And the function works even if the service is not enabled. So the idea is to somehow trigger an authentication from the DC to the machine that has unconstrained delegation enabled. Right? And once you have the TGT, then we can inject it using Rubius and then run the DC sync attack. No need to even create a silver ticket. All right. And this would bring us to learning objective 15. Find a server in the $corp domain where unconstrained delegation is enabled. We've already done this. We know that dcorp FSRV is one such machine. Compromise that server and escalate to domain admin privileges and also to enterprise admin privileges by abusing printer bug. Our question is, how do we know if the target is running spooler? I mean, it used to be turned on by default. Now a lot of organizations stop that. But I'm unaware of any way to check it. I mean, just run this and see if you get it. I mean, yeah, that's what I know about it. What does the PTT? Okay, that is answered. So the question was, what does this PTT do? That's a shorthand for pass the ticket. So it injects the ticket in the current process. Yes. So if your spool sampler or MS-RPRN doesn't trigger an authentication, then go for petty put on. All right, let's try this. So we have found out that it is the dcorp FSRV that has the unconstrained delegation enabled. Now recall that when we run Mimicards on dcorp admin SRV, we got credentials of a user called app admin as well. And we discussed that whenever we get access to a new user, it is worth checking if that user has local admin privileges on any other machine. All right. So from dcorp admin SRV, we extracted credentials of a user called app admin. And we will find out now that app admin is a local admin on dcorp SRV. Let's check it. So we need to start a process as the app admin user. All right, using overpass the hash. We started a process as the user app admin. Now using find PS remoting local admin access from InvisiShell, I mean, we'll run it from InvisiShell. We will check if this user has local admin privileges on any machine in the network, in the domain. So the user app admin has admin privileges on dcorp FSRV and admin SRV. So dcorp FSRV is the one that we are interested in right now. All right, this process is running as app admin. So let's use that to copy over Rubius to the target machine. All right. Now let's access dcorp FSRV using WinRM and run the monitor. So we are running Rubius in monitor mode. We need to check for a TGT every 5 seconds. TGT for what user? dcorp DC $. No other user. Please keep in mind that on D Corp FSRV, if you want, you can simply go ahead and extract all the tickets. There is a simple simulation that leaves a ticket of the default domain administrator account on D Corp FSRV. So if you want to try that way, check out the lab manual. There would be no need to use Rubius in that case in monitor mode. But here we are discussing the printer bug. So let's run this in the monitor mode here. And from a normal command prompt on the attacker's machine, we can simply go ahead and use msrprn.exe. And we ask dcorp BC to notify us on dcorp SRV. Let's run this. All right, we got an error here, but we should still be able to get a TGT of dcorp DC dollar here. This is the base 64 encoded TGT that we need to copy. And here we can use rubius.exe and it's PTT option /ticket, and we paste that base 64 encoded ticket. Let's run this. Ticket successfully imported. If you run klist, you would see here that we have a TGT of dcorp DC dollar. Okay, we need to run it from an elevated shell because safety cards need that. Let's copy all of this and run this from an elevated shell. And now we can run at least the DC sync attack. Please note that the domain controller machine accounts or any machine account by default cannot interactively log on to a machine. All right, and here you can see that we have the hash of the Kirby TGT account. This is how we can abuse the unconstrained delegation. A question is xcopy, the copy command that we used, less noisy than copy item? Or is it more that it is not hitting the logs the same way? If you suspect that your target organization is using PowerShell logging, then xcopy is the way. However, please keep in mind, even xcopy is not a very OPSEC safe command. Right? It is known to be used by attackers, but there are a lot of options. For example, you can check out the LOLBAS project. There are many Microsoft signed binaries that you can use to download stuff. All right, anything, any tool that does the stuff for you and is not very well known can be used there. I mean, the good thing is with these tools is, I mean, tools like, for example, just not net.exe, anything other than that stands out when it is tested in a lab environment. In a production environment, a lot of times it is very hard to differentiate if it is an anomaly, an activity that stands out, or is it something normal. So it depends a lot on that. All right. Moving on to our next topic, continuing the discussion on delegation, constraint delegation. So we understood that unconstrained delegation sucks, right? It's very risky and you should not use it. And Microsoft realized that as well. So unconstrained delegation, if I remember correctly, was introduced in Server 2003. In Server 2008, constrained delegation was introduced. So constrained delegation, you can once again use these reference slides later. The idea behind constrained delegation is that you restrict the services that the first hop can access. In case of unconstrained delegation, the first hop can access any other resource as the user. But in case of constrained delegation, the first hop can access only a particular SPN, a service principal name. That is only just one service on one machine. That is the idea. Now, the more interesting part of constrained delegation is constrained delegation with protocol transition. What is that? In case of protocol transition, a user that authenticates with the web server from a non-Kerberos compatible authentication mechanism has to be transitioned to Kerberos. So how that is done? Let's take a look. So this user here authenticates to the web server using a non-Kerberos compatible auth mechanism. For example, form authentication. What is form authentication? Let's say when you type gmail.com in your browser and provide your credentials. That is what form authentication is. So that is step one. The user authenticates using non-Kerberos compatible authentication mechanism. Now the web server must transition this authentication to Kerberos. All right. Now this is how the web server service account executes the transition, or this is how protocol transition works. The web service requests a ticket from the KDC for the user's account without supplying password. Listen to it slowly and carefully. The service account, the web service account requests a forwardable ticket from the DC without supplying a password. What does that mean? That means that the web server starts authenticating users out of thin air. Why? Because the KDC checks for only a couple of things. One, is the web server service account trusted to authenticate for delegation? That is, if constrained delegation is enabled on this service account. And second, if the user whose account or for the user for whom the ticket is being requested, is that user blocked for delegation? If these two conditions are met, the DC responds with a forwardable ticket for the user's account. Now, the problem is that DC nowhere validated if the user, who we are calling Joe here, if that user actually ever authenticated here, because the DC has no visibility of that. What does that mean? That means the web server can go ahead and request a forwardable ticket even for a domain admin, and the DC will oblige, the DC will provide the ticket if these two conditions are met. All right. This is problem number one with constrained delegation with protocol transition. Now, at the end of step three, the service account then sends this ticket back to the KDC and requests a service ticket for this service. What is this service? This service must be specified in an attribute of the web service account MSDS allowed to delegate to. Now, MSDS allowed to delegate to contains service principal names of those services that the first hop web service is allowed to delegate to. So the DC will check if this request or this SPN is present in the MSDS allowed to delegate to. If it is present, then it gives a TGS, provides a TGS to the web server. And finally, the web server can then present the TGS to the file server and thereby completing the impersonation. All right. This is what constraint delegation with protocol transition is. Now, the second problem here is in MSDS allowed to delegate to, but we will address them one by one. Let's address this problem, authenticating users out of thin air. So first, we will enumerate any users or computers that have unconstrained delegation enabled. So we can use get domain user or get domain computer trusted to auth from PowerView, or simply get AD object from the Active Directory module or the AD module. So let's first run that. So if I run get domain user trusted to auth here, we will get that there is an account called WebSVC that is trusted to auth for delegation, that is constraint delegation is allowed. And it has this MSDS allowed to delegate to property. What does this mean? This means that the user WebSVC can access this service on dcorp MS SQL as any user, including a domain admin. And there is no need to trick or force a domain admin to connect to this service. We can simply go ahead. If WebSVC is compromised, we can access this service as that user without having to force a domain admin to connect to it. Now, how do we abuse that? How do we abuse the access to WebSVC? So we need either plain text password or NTLM hash or AES key for the WebSVC account. We already have it from dcorp admin SRV. That was an important machine, gave us so many credentials. Now, using the NTLM hash or AES key, we can either use Kikyo. Kikyo is a tool written by the same guy, Benjamin, who wrote Mimikatz, a very useful tool. Or we can use, so we can request a TGS using Kikyo and use it with Mimikatz, or we can use it with RubyS. So what are we doing here? Using the S4U module of RubyS for the user WebSVC whose AES key is this. We want to impersonate the domain administrator, and we would like to access this service that is specified in MSDS allowed to delegate. That is what we want to do here. So let's go ahead and do that. Let's purge all the tickets from this process. So once again, we already have the AES keys of the WebSVC account from dcorp admin SRV. So all we need to do is run this command. Run this command. If you run klist now, you would see that we have a ticket for domain administrator for this SPN. And now we can simply go ahead and access it as a domain admin. However, please keep in mind when I say that as domain admin, that simply means as a local administrator. We are able to do this because a domain administrator, by default, domain admins group is added to the local administrators group of a machine when it is onboarded to a domain. All right, if I clear this ticket and then try to access, okay, the ticket was not cleared probably then. Let's try from a new process. Okay. All right. So that was problem number 1. That is the web server. So what we address right now is that the web server can access any resource. Not any resource, the resource specified in MSDS allowed to delegate to as any user. That was the first thing. However, there is one more problem. And this is more severe actually. If I run get domain computer trusted to auth here, we'll get one machine, tcorp admin SRV, once again, that has trusted to auth for delegation set. What are its MSDS allowed to delegate to values? It is time service on dcorp DC. Now, a problem with this is, this is the way how constraint delegation works in Active Directory. This account can access the time service on dcorp DC as any user, including the domain admin. But not only that, this account can access all the services that share or that run with the same service account as this service. And this actually makes it huge. Why? Because all the interesting services use the machine account as the service account. So the time service uses machine account as a service account, partial remoting, that is WinRM, HTTP, that uses machine account as a service account, RPCSS, machine account as a service account, and so on. This means that not only we can access time service on the domain controller as a domain administrator, we can access WinRM or WMI as well. And that would be very interesting. How do we abuse it? Absolutely the same way. We just need secrets of the account, dcorp admin SRV, and then we can either use KQO plus mimicards or Rubius. The only difference here is this. So in the previous command, there was no alt service option. Here, what we are saying that, okay, the SPN specified in MSDS is this, but we would like to request a ticket for an alternate service called LDAP. So why are we choosing LDAP here? Because we have, so that we can run the DC sync attack here. Let's try this one now. Make sure that when you are trying this in the lab, that you have the latest hash of the dcorp admin SRV account. All right. So let's run it from an elevated shell. It is an elevated shell. So let's run this command. Note that we are requesting ticket for an alternate service. And let's run the DC sync attack now. And as you could see, we can. All right. This is what the problem with constraint delegation is. There were two tasks here. We have completed both of them while discussing this. So any questions here? We have two tasks where one, we had to abuse a user that has constraint delegation. Second was to abuse a machine account that has constraint delegation. Right, if we look that in the diagram, we abused constraint delegation on web SVC to gain access to dcorp MS SQL. That was one. And the other one was on the DC. So I probably DC sync using dcorp DC dollar TGT. That was the second one. All right. Now, there is a third type of delegation as well, and that is the last thing that we are going to discuss today. So Microsoft realized, okay, constraint delegation and constraint delegation with protocol transition is something that is still problematic. All right. And as we saw here, the biggest problem, in my opinion, is that there is no user interaction required here. All right. So there is a third type of delegation that was introduced in Server 2012, resource-based constraint delegation. Now, the idea is that in case of both unconstrained and classic constraint delegation, the authority to configure it is with the domain administrators. All right, the rights required for that are SE-enabled delegation privilege. Right, that is the privilege required to set up unconstrained delegation or the classic constraint delegation. But in case of resource-based constraint delegation or RBCD, the delegation authority is now moved to the resource administrator or the service administrator. That is, in place of the front-end service and its MSDS allowed to delegate to attribute, the access now is controlled by security descriptor of MSDS allowed to act on behalf of other identity, which is visible as principals allowed to delegate to account on the resource. That means that now it is the resource administrator or the service administrator who can configure this delegation. All right, so this not only takes off it reduces dependence on domain admins, it also lets the backend user, backend resource administrator to decide who should be allowed to access the service. Right? But that also means that if we compromise a service administrator, then we can abuse RBCD. So there are just two things that you require to abuse resource-based constraint delegation. One is control over an object that has SPN configured, for example, an admin access to a domain join machine, or simply access to a normal domain user. By default, a normal domain user can join up to 10 machines to the domain. Second, write permissions over the target service or object. That is, ability to pose as the resource administrator. So in our lab, we already have administrative access to the student VM. So this is already, we meet this prerequisite already. Let's check for the second one. So if you run some enumeration, we will get that. I'm not going to run this because that takes some time. But if you run this, for example, or if you look at the Bloodhound output, you will find out that CI admin has write permissions on dcorp mgmt. All right. That means on the reverse shell that we got using Jenkins, we can actually set up RBCD on dcorp mgmt for student VMs. That is, we go ahead and configure on dcorp mgmt that the student machines are allowed to delegate to this account, and then we can go ahead and access dcorp mgmt as any user. All right. So for example, if I set it up for dcorp student $1 student VM, I extract the AES keys for that account and then use Rubius as user dcorp student $1, provide their AES keys and request a ticket, HTTP ticket as the domain administrator. And then I would be able to access DCorp MGMT using WinRM as the domain administrator. Why? Because we are configuring RBCD on DCorp MGMT. All right. And this is learning objective 17, the last thing that we are going to discuss today. So ask me again if you want me to explain this in the next session again, I will do that. However, I think that because the commands are pretty straightforward, so we should be able to cover this. All right. So learning objective 17 is find a computer object in the DCorp domain where we have write permissions, abuse the write permissions to access that computer as domain admin. So let me do that. I believe I should cover that in the next session again. So here, let me start Netcat listener here. And let's get the reverse shell back here. So that we get the privileges of CI admin. Why? Because if we run this command, you will see that CI admin has the right permissions on DCorp MGMT. That is our prerequisite for abusing RBCD. All right. So here we have our reversion. So we would first bypass script block logging here as we did earlier. Then we will bypass AMSI or MZ here. Then we will download and execute PowerView in memory here. Why? Because we want to configure RBCD on DCorp MGMT. Here you may note that when I'm running the command, I'm configuring it not for only for my own machine. My machine is DCorp student 1. Yours may be DCorp student X or STDX. Please keep that in mind. So I'm configuring it for a couple of more machines so that I do not keep overwriting it for others. So let's set it up. And now if I run get domain RBCD, you would see that on DCorp MGMT, RBCD is now set up for this machine, and all the machines that we specified, including the student VM that I am using right now. All right, so that is all that we need from this reverse shell. The next thing that we need is AES keys for the student VM. So let's use safety cards for that. We need it from our own machine. Please keep one very important thing in mind. You may find multiple AES keys here. See that? DCorp student $1, this is the AES key. DCorp student $1, this is also the AES key. But always keep the security identifier in mind. This is a virtual account. You want this one. What is this? This is a well-known security identifier for system user. So this is the key that you need. Let me copy that. And finally, we can simply go ahead, excuse me, and run rubys.exe. S4U is the module that we are using. Excuse me. dcorp student $1 is the account. This is the AES key that we copied. We want the ticket for this SPN, HTTP on dcorp MGMT, and we want to impersonate the domain administrator. Let's run this, check if we have it. Yes, we do. And now we can go ahead and access dcorp MGMT as the domain administrator. However, please keep in mind that this is a TGS. You cannot jump from dcorp MGMT to any other machine as the DA here. All right. So we used here the keys of the system user, of course, because that is what you would like to use. That is what has the RBCD set up for. It is the system account, machine account that has the RBCD setup. That is why we used its keys. All right, so that was our learning objective 17. All right, do we have it for RBCD here? Yes, we have used our RBCD to get access to dcorp MGMT. And that would be all that I will cover today. A couple of questions that I saw but could not answer was, if you want to check how long you have access to the lab, check out the lab dashboard. All right. This is your last lab date. That should be, I believe, for your batch, it could be what, for most of you, it would be 5th or 6th of February. That is almost a week after the last day of the class. Okay, noted. I will repeat RBCD in the next session. Just ask me if I move ahead, just ask me and I will repeat it. Your last date to attempt the exam would be this. I glanced over some discussion on when should you do the exam. I would say if you are practicing the lab well, do it soon once your lab access finishes. All right. The reason why I say this is you would have, no matter how much fair I would like to create the exam, there is always a trait. I mean, when I design an exam, it would have a certain flavor. So if you recall how what the things that I discussed in the class, if it is fresh in your mind, it would be easier for you to clear the exam. Please always keep in mind, CRTP is an entry level. We treat it as an entry level certificate. We want you to clear this exam, right? So of course, there are some minor tricks and gochas here and there, but if you have done the lab well, you would absolutely be fine with the exam. The question is, if you extend the lab, does an exam attempt come with it? Yes, it does. All right, any other question that I might have missed? So if we extend the exam, we could have 2 attempts. Yes, that's right. All right. Thanks a lot. Thanks a lot for all the kind words. Okay, because there are no more questions. Okay, there is one. When we click setup exam lab, it will start immediately. Yes, it takes a setup time of 15 to 20 minutes. But yes, if you call that immediately, yes, that is immediate. Thanks a lot, Speedlo. All right, then I'll stop this one and see you in the next session, and of course on Discord as well. All right, see you later then. Bye-bye.